Good morning, everyone. I've already been introduced, so without further ado, let's get started. I think most of you would know Warren Buffett, third or fourth richest person in the world, big philanthropist. His message, I wanted to sort of start with his message because I think a workshop like this, as Professor Patwardhan says, so there will be some of us who are sharing our experiences. And I think it will be a mix of mistakes and successes. And uh, if you have not tried these yet, then perhaps you can learn some lessons from these and make sure at least that you don't repeat our mistakes. So in significant part, I will be talking about mistakes. So that's why this started. So in some sense, my talk is divided into two parts. I want to share with you my journey of how we reached a point where we were doing a ET type experiment in my classroom. Um, it started before, and I want to share that with you a little bit, and maybe it will help. You can ask me some questions. So here is my background in terms of teaching. So prior to joining IIT Bombay as an assistant professor in 2009, I had almost no teaching experience. I did go through a TA training um, at the University of Texas at Austin, which was very interesting. But throughout my stay there, I was a research assistant. So the only teaching experience I got was, once or twice um, having a sort of teaching a tutorial session for my supervisor, etc. So it was nothing really. And so after I joined IIT Bombay, I taught PG courses for the first couple of years before I was assigned a UG course. And this, in a sense, is where the journey begins. I thought that, what do I know about UG teaching other than my own experience? So I thought I would go check out, discuss the people who know about teaching. So I looked up educational technology, and at that time it was a much smaller department. The only full-time faculty there was Professor Sahana Murthy. Sorry, I got the name wrong. The last name by mistake. So Professor Sahana Murthy was the only full-time faculty there at that time. And just to be clear, I did know that that ET is a full-fledged research program. I did know before I approached her that it's not the job of our EP colleagues to give us these teaching tips. So I only appealed to her collegiality, and she was very, very helpful in pointing me towards learning outcomes, flipped classrooms, peer instruction, and so forth, similar to what she did for all of us today. So for me, it was back in 2012 or so, one-on-one meeting where I came back with lots of tips from her and pointers, and I started reading up. And then I started using those techniques from that time onwards in courses almost continuously in UG and PG courses that I taught. Most of those were related to semiconductors, and I won't have a lot of specific details. I won't be showing a lot of specific details, be it learning outcomes, etc., because they tend to be domain specific. So they will be somewhat generic, but I will, if you have any questions, something is not clear, please post them and I'll try to clarify as best I can. And once again, I'll, like Professor Sahanamurthy, I'll point out that I'm unable to see the chat window, etc. right now when I'm sharing my screen. So I'll request maybe Dr. Mrinal Patwardhan to help me with, interrupt me if there are questions. You can also directly interrupt me as well, no problem. And I just wanted to point out, so one thing we sometimes struggle with in the flipped classroom mode is we feel we have to generate new content, and then the exercises that you plan for class, if the students are going to watch the video content earlier, that can be quite a lot of work if there are all these learning outcomes you have in mind that you want to test and prepare the students for. So in fact, once or twice I used very high quality lectures in this domain from Purdue University, which has one of the top programs in the world in this area. And in fact, after using it once, maybe twice, I figured out that we need I wanted to do it a little differently. I mean, it was very heavy duty content, a lot of it thrown at the students, and I wanted to sort of narrow down on a few of the fundamental concepts and not throw everything at the students. So I started building up my own content as well, video lectures. And this was quite a bit before COVID, by the way. So when COVID struck, I was reasonably well prepared. Okay, so what has been my learning, if I want to summarize that over the time I have been teaching, is that I started out, and I feel it's a mistake to avoid, is to throw too much stuff at the students. And initially, it felt unjust to not do so. What I mean is that, in the semiconductor area, I have been in this area when I started teaching, I had been in that area for a decade. I knew about, its interaction with physics and material science. I knew about how it applies in industrial settings. I knew a lot, and I felt that, if I didn't transfer all of that knowledge to the students, I'm not doing right by them. And now I have reached a minimalist approach. This is now my philosophy, that I try to focus on what I consider the non-negotiable fundamentals, and I'm happy if I try to sort of narrow down on those few things, and I try to relentlessly focus, and I tell the students that there is a relentless focus on these 4 things. If you go out of this course, I want you to be able to do these 4 or 5 things. And we come back to that to those 4 or 5 things in various ways. And I tell them, and I think that, and it's true for most of us, that our students will not be doing all the things that we are trying to teach them in a particular class. If they do it at all, if they even stick to doing science and engineering, even then they will be maybe doing something else, maybe using a small fraction of what we are teaching them in a particular class. So that is why I feel now that it makes sense to focus on a few things and do it rather well, so that it sticks. I mean, not throw too much stuff, but whatever we throw, make sure that sticks. And in part, how I realize this is let me illustrate that with a little example. This is not very, I won't go into the details, but let me just tell you that there's some physics type derivation which is taught in semiconductors. It's taught in the textbook, and in a most traditional classes, it would be taught in a 3-dimensional context. So that is what I did the first time I was teaching that course to undergrads. And I thought that, these are all very brilliant students, and I just asked them to do the corresponding 2-dimensional derivation in the exam. Unfortunately, most of the class did not get it. Overwhelming percentage of the class did not get it. So I thought, I understood that it might have been very tough, but I did not think too much about it. The next year I was teaching again the second year undergrad, same course, and I thought I'd make it easier for them. So this time I taught them the 3D in the class. Then in a tutorial session, I taught them the 2-dimensional example which had appeared in the exam the previous year. And in the exam, I asked them to solve the 1-dimensional case. And still very few people got it, very few. So that really made me kind of sit up and think about how I had, learned these things. And I remembered poring over a somewhat advanced book spending hours with a advanced book for some of these concepts. And I realized that I had forgotten that it must have been very difficult for me after 10 years. I forgot that these must have been very difficult for me too. And that in part is how also I reached this minimalist philosophy. So this is one aspect. The other aspect is, um, this chewing on concepts, and Professor Sahanamurthy just took us through a sort of formal vocabulary for that, and I'm also going to flash that in a second. But in discussions with her from the very beginning, when I thought about my own learning and how I learned things that I think I understand very well today, it was intuitively clear to me that I have learned these concepts more through this process of what I'm calling chewing on the concepts than just the transfer of information that happened in class. And I'm not from ET, so I can't answer the question of whether this is true of all of us. But of course, the ET research is suggesting that it is. So then the question then becomes, how do we catalyze what I'm calling the chewing process? How do we have more of that? Because as we have figured out, especially in COVID times, the transfer of information is not a big deal. To prepare some video content and post it is not a big deal. All of us are doing that now, day in, day out. So it was in that context that, I came upon this Bloom's taxonomy. Professor Sahanamurthy has talked about this, and I don't need to anymore. Other than to tell you that this was part of my journey was to think about these things as I prepared learning outcomes, as I set about um, preparing the exercises in the flipped classroom. I was, once the video content is there, prepared by myself or by somebody else. After that, my work was to prepare questions and exercises, and those would be done in these modes that Professor Sahanamurthy mentioned: peer instruction, and I will mention one more called think, pair, share. So those designing those exercises was the real work after that. So that is, and I sort of then was consciously asking myself whether I am incorporating these different um, dimensions into my the student activities that I was designing and the assessment, the tests that I was designing. So with that, maybe I'll pause here for a little bit, because after this, I'm ready to now talk about the experiment that me and my TAs did with Professor Sahanamurthy and her students in ET. Maybe I'll pause here, and if there are any questions or comments right away, take a look at that.
So, do you see this bare minimum content which you said, bare minimum non-negotiable fundamentals? So, do you make them clear to the students that these are the components that will be non-negotiable?
Yes, absolutely. So in fact, the learning outcomes say that, and these aren't that many in number, and that helps. And I keep coming back to that. I keep telling them that now we'll do an exercise on. So there's a. Let me take a specific thing. There's this exercise we do where we illustrate various energy levels. There's a thing we do in semiconductors, very common. It's called drawing a Venn diagram. So we draw energy levels, and in various contexts. And each time I come back to that, I tell them that, look, remember I told you that this is something that I want you to remember 5 years from now. Or if you are graduating from this course, this one skill you got to take with you, how to draw this energy level diagram. So yes, I do make it clear in the beginning, and I sort of reinforce that pretty much every chance I get, which is often. Okay, let me ask Dr. Mrinal, is there any other question on the chat? Otherwise, let me proceed.
No, at present there aren't any questions on the chat, so I think we can continue with the session. So maybe people will have some questions at the end of the session.
Sure, sounds good. Yeah. Okay, so this slide, without the quotes at the top, and you will see why the quotes are there. This slide is verbatim from my presentation slide deck from my promotion interview. I know, especially if I mean, some of these workshops are significantly have our junior young faculty colleagues in mind, and we were seeing some questions come up in the previous session on, from colleagues who are maybe teaching for the first time. So, and in many of these cases, this would be perhaps on your mind that, teaching is something. Our deputy director talked at the beginning about how it's a part of, how the institute evaluates faculty. So therefore, I thought that I would show you this this slide. So when I went up for my promotion, then I had two slides on teaching. One of them just summarized all the teaching scores from the ASC interface. That is really of no interest here, I guess. Anyway, it has been discussed in the in my promotion committee. So this slide, the second slide that I had on teaching, let's talk about that a little bit. Not on this part. This is it is a nice looking demo that I did in a theory class, which normally doesn't have any experimental component. But about this part, which I'm significantly supposed to talk about. So this was an experiment we did with Professor Sarnamurthy, and I'll draw your attention to the highlighted portions here. There are two portions, and these are the two take-home messages. One is that, what it was is a study of a flipped approach for a postgraduate EE course. And the instructors, by which we meant here myself as the faculty, as well as my teaching assistants from electrical engineering and educational researchers. So Professor Rasanamurthy, who was guiding the study, and a bunch of her students. Two of them were co-authors in this paper, but a few more of them had other roles in the work, which I'll tell you in a minute. So it was a collaborative approach between these two teams. And the second take-home message is here in two parts. First is the ET researchers, and this is what they were doing. They were sitting in our class, usually 5 of them, like PhD students, and they were doing their observations of what the students were doing, whether they were engaged, whether they were looking at the board, whether they were writing when they were supposed to do something. So they were observing engagement, and that is what this refers to 65% of the time. And the last part, I will talk about this in a minute, is whether they were able to address in the exam a new concept. So that also we focused on, and that got reported on in this paper. So let me kind of expand on that in a little bit. And after that, I'll also request Professor Sahanamurthy to comment. So here it is. As I already mentioned, so we took a flipped approach, flipped classroom approach. These were voiced over slides prepared by me for before class viewing. And one question which came up, and again here, tip from Sahana helped. So, okay, we mandate, like we mandate attendance, we can mandate that students should view the lecture before they come to the class. Otherwise, there's no point being in the class if we are going to have exercises based on that material. But how do you make sure that they do look at the material before? And what I have done since almost the beginning is we would give them randomly about scattered throughout the duration of the course. They would be randomly given 8 to 10 quizzes at the beginning of the class. And they wouldn't know on which day I would give them this random quiz. Very small weightage, but it's free points if they have gone through the material. And my instruction to the students was that I will be only testing whether you have gone through the material, not whether you have understood the material, because my expectation is that you will have understood it after the discussion. But at least I need to know that you know what's in the video. So that was the modality here. And then in the class, we would do the problem solving and discussions. So Professor Sahanamurthy mentioned about peer instruction. My students in my classes, again, based on a tip from her, there are electronic clickers also, which will let people vote, and you can see it on a screen. Maybe we'll have infrastructure to do that in the future. But what I was doing is a low-tech version where students would have a piece of paper on which they would make 4 quadrants and write A, B, C, D, and they would hold up A, or they would fold the paper and hold up A or B or C or D, depending on which way they wanted to vote. And then TPS or Think, Pair, Share is an exercise where you first ask the students you give them a little bit of time to think for themselves once a question is posed, then pair. So they discuss in pairs and they come up with an answer, and then a subset of the pairs are asked to share, and then you have a discussion around that. So all of this, the student engagement, as I mentioned, was observed by the ET PhD students, aided by my TAs from electrical engineering. And I'll take a minute to tell you what aided means. So this paper, it kind of took up specific examples of, let's say, the one I used before of drawing energy level diagrams. That makes it finds explicit mention in the paper. So that's one example of where the electrical engineering TAs actually provided the context of the domain to the ET researchers, ET PhD students, Professor Sahanamurthy's team. So that is how this came together. Then let me tell you about something which I felt was a very interesting and somewhat ambitious study, but which didn't work out very well. So we set up quizzes for what is called, well, actually instruction and quizzes for what I believe our ET colleagues call an AB kind of study, which essentially, to put it very simply, as I understand it as a non-ET person, is we take up 2 non-correlated topics, and they are taught using different techniques, the traditional and the flipped approach. And then we give them tests on these 2 topics, which have to be of equivalent difficulty. And then we have a comparison of, which one is working better or differently. I mean, you have a comparison between the traditional and the flipped approaches. So I was really very excited about that, and I remain excited about trying out these things. But what I figured out, and here is a mistake to learn from, the tests turned out to be too tough. So we decided that we would kind of shelve this for now, for then, and we would come back, and whenever this I was teaching this course next, which I expected would happen thereafter in the next year, then we would come back and we would kind of do this over a few years, but that didn't happen because of various logistics of how courses are assigned to instructors. But we took that learning, and this is what Professor Sahanamurthy was mentioning, that there was this adjustment that was done for the end semester exam, the relearning. And what I did there, so the NSEM, it kind of broke up the problems that might have been too tough into simpler parts, but parts that still kind of touched upon those different aspects of the Bloom's taxonomy that you were looking at earlier. Not only remembering and applying and analyzing, but also evaluating, judging, and components of design. And the second take-home point in that paper was exactly this point, that at the end of it, um, and again, this kind of happened, it was very obvious to us that this had happened, but there was a kind of a little bit of an aha moment when it was our colleagues in ET who realized that this had happened. We did not realize that this is what had happened, that students had synthesized information very successfully on a particular problem. So there were two different things that had been taught to them, and the problem required them to kind of bring those two together. And because it's something that, again, we in the domain do that particular thing, as a matter of routine habit. So we didn't even stop to think that that is what we were doing, and that is what the students had done. But that is what had happened, and a surprisingly large percentage of students had done that successfully. So that is the summary of that collaboration. I'll stop here for a couple of minutes, and maybe before taking any questions, I'll request Professor Sahanamurthy to comment or add or correct, maybe. Sahana, if you're here.
So thanks for all this. This is very clear, and thanks for all the. I have a lot of noise here, so I'm going to switch off my mic. But it's fine. I'll have to take questions.
Okay, so I'm going to end with this slide. This is the last slide I have. So and it says personal experiment. So I do look forward to trying out new things in the classroom. I'm not necessarily recommending it for everyone. Like I said in the beginning, there are two parts to this. One is to take what is established in the research literature and plan the courses with let's say learning outcomes, things like that. And then you can try to do more things, experiments, and if our ET colleagues are interested in some of those experiments as research problems, then that becomes overall a very interesting proposition. So I just wanted to share that what I would be looking forward to. One is starting with the second one, is that there are collaborative classrooms which have now come up in the institute. So one is in the DEAC CAC building from PPCCLT. I think Professor Sachin Patwardhan and Dr. Mrinal Patwardhan can tell you all about it. And then there is another one coming up in EE. When it does come up, then we'll come back and tell you guys all about it and invite you to consider using that infrastructure for your teaching. This is a picture from the so-called scale-up program in the US, which is multi-university teaching learning program. And you can see that they have these special classroom designs which kind of catalyze collaboration, because you are in a round table rather than everybody looking at the teacher, the instructor. Here, students are really sitting around themselves, and is fairly clear that it's a more effective setting for peer-to-peer learning. So these are coming up, and I'm looking forward to using these for teaching. And the second point on top is, it has come up on top because the students are not around to use these to be in our classrooms. So I will be exploring an online platform for student collaboration. It's like a social media for your classroom. I don't know how it will go, but I'll try that out in the next semester. And we have a offer from the same alumnus donor distinguished alumnus of IIT Bombay who funded this collaborative classroom in EE also has an offer for us to pay for the software if we like the software. So that's what we'll try to do. If you have any questions on any of these, then please feel free to write to me. I'll also post or call me. I'll post my number if you want to chat. And I just want to acknowledge Professor Sarvanan from Electrical, who's kind of driving this effort. And if he has any comments, I'll request him to speak up. Sarva, anything to add? If you are here.
I don't have anything to add. So we expect the classroom to be ready maybe by the end of this year, but we'll keep you updated. I think it's being renovated. And of course, thanks to the CD. So the classroom was previously a CD classroom. So I would like to acknowledge the C there and the CD for allowing us to convert it into a collaborative class.
Swaroop, I'll just, what I realized that in the beginning, my presentation wasn't shared. I think I'll just share briefly a photograph of the classroom that is ready. Yeah.
Yeah, I'll just stop sharing so you can
Yeah.
connect.
Professor Swaroop, there is a question from Professor Jai Ghosh. Maybe later on you can take it up after Professor Patwardhan completes his presentation.
I just want to
sounds
show
good.
one slide. I didn't realize that in the beginning my slides were not visible. So this is the classroom which Swaroop talked about. This classroom is in new energy science and DESE CESE building. On the first floor, this is the institute facility. This will be available for any course on booking. We'll be making a booking system, and we hope next semester when physical classes start, this can be used for elective classes. Is my screen visible?
Yes, nice.
Yeah, it's visible.
So this is the photograph from and if you go to our web page, you will see a detailed presentation on what are the facilities available and how it can be used for teaching. Maybe you can look at it and start planning your course in the second spring semester based on this. So I'll stop sharing and hand over to.
Actually, I have one comment to add regarding the collaborative studies. So there is a lot of in-house experience in the PPCCLT itself. Dr. Mrinal Patwardhan herself has a PhD in educational technology, and she has a master's background in electrical engineering, and she's taught in at the UG and PG level in engineering colleges in Bombay for 20 years. So that would actually be a first place to start, because she's done a lot of such handholding with, I think, many other faculty in the institute. I just wanted to put out this resource. Mrinal, sorry, I didn't ask your approval before sharing this, but I'm sure you'll be happy to do that.
Yeah, certainly. Thank you.
So, Swaroop, I have one question. Did you actually split the class into two and then taught the entire course in traditional way to one group, and or it was only some sections and using active learning for the second group? Was it for the full semester, or was it, or the entire class did everything through active learning?
No, yeah, let me answer that question. And I'm sorry, this should have been clear from my presentation, but sorry if it was not. I mean, clearly it was not. So let me clarify. So one way to do this kind of comparison is indeed to have two sections. And I think there was a study like that from our chemical engineering department, some basic course which was taught by two instructors, splitting the class into two sections, one taught in the traditional mode and another in the flipped mode. No, I did not have that luxury. I mean, yeah, the bandwidth also to really take two different sections. Also, it has its own complications in terms of these two sets kind of interacting with each other. So the splitting here was not in terms of splitting the class, but in terms of splitting the topics. So there is a topic A, which is taught in the traditional mode. And there is a topic B of equivalent difficulty, let us say, and not correlated, not connected to topic A, which is taught in the flipped mode. And this is repeated with two other topics, again called A and B. But so you have 4 different topics of equivalent difficulty level and not connected to each other. Well, A and A could be connected. A and A are the 2 topics which are taught in the traditional mode, and B could be connected, where B are the topics which are taught in the flipped mode. So that is how the splitting happened. And these were sort of modules within the class that I was teaching. So the whole, the rest of the things was taught using the flipped mode, but there was an experiment which involved 4 modules, which had to be very kind of carefully selected and treated. And in the end, was not treated with enough care by me. So it has to be done better. Did I answer the question?
Yeah, yeah.
Sahana, did I get that mostly right?
Yeah, absolutely, Swaroop. So I just want to mention overall, so this design is often used in educational interventions because the randomized control trials or 2-group method, while they are, in core psychology and known to be gold standards, but they come with both logistical difficulty and also ethical difficulties. Because if we know, at some level, as an instructor, we know that an intervention is likely to work or it's beneficial. So it is an ethical issue also to withhold it from the students. So from one group of the students throughout the semester. So in one of the previous studies in CS 101, it was the same instructor teaching 2 sections of about 250 each. What he did for some topics was he taught the 2 groups differently. But then for the next set of topics, whoever was taught using Think, Pair, Share was given the traditional treatment and vice versa. So he that's called a cross design. So that can work if you naturally have 2 sections which are equivalent and so on. But those are real logistical issues to be solved in an organic educational setting. What Swaroop did actually is a little easier for an instructor, and there the main care is that to make sure that the topics are equivalent, not correlated, because you establish a baseline, then do intervention, then withdraw and do it again. So this is very much doable, and it has a fair amount of acceptance in the research community also.
So now suppose I have my lectures recorded ready with me. I should be spending more time in designing think, pair, share questions or topics or conceptual questions that would initiate discussions in the class. So during the semester, it should be more spending time on design of formative assessment and both summative assessment, Mark.
Yeah, that is what I was doing, but perhaps Sahana is a much better place to take this question.
Swaroop, your experience is much more first-hand, so it's definitely needed. So, Sachin, yeah, definitely that would be one way to go. Just one comment here, again, a recommendation that is there, that in the videos, so like Professor Sudarshan said right at the beginning, the instructor's role these days is no longer to do information transmission because it's there in the videos, the live instructors, or the web has it much better than any individual instructor and all. Instead, our role is to do the kind of things that you just mentioned, Sachin. The higher order thinking, the problem solving and all, let's spend time, the synchronous time or the in-class time on that and push the simple information transmission to the videos.
Okay.
Dr. Mrinal, you had said there was a question.
There is a question, hand raised by Professor Jai Ghosh. So, Professor Ghosh, will you unmute yourself and ask the question?
Yes, thank you, Professor Murthy. Professor Swaroop, thanks a lot for the nice presentation and giving out some of the pointers. I had a couple of questions for you. One of them is that I am also this time, since last time when this semester was running a year before, I had done very good quality pre-recorded lectures and all, which I also plan to use this time. And I really liked what you said about the part that after you give them some like material for say a chapter, next time you're having a live interaction in the beginning, you do around 5 to 10 conceptual questions just to see that whether they have grasped the topic or not. So I wanted to ask that what was the sort of the level of difficulties that you set in, and where they the course which I'm going to teach is a mix of good amount of theory as well as a lot of problems. So where your questions mostly just theory based, just to see whether they are able to understand how a particular formula is derived, or did you also throw in a few simple example problems and so on? So that is my first question. And my second question is that I saw that you touched upon some platform for online collaboration that you're planning to test it out now. I also plan to do that because last time through Moodle, I did some discussion forums and some hot questions, because one of the things is that even in regular classroom, you can at least sometimes pick on some of the shy students and encourage them to ask questions, but through the online mode, it becomes difficult. And sometimes the student may feel that the question is rather stupid, and what will others think of me if I ask this question. So I created some of the discussion forums and hot questions, but last year, although the course reviews and all came out well, but there were not many participants in these discussion forums, maybe because of these kinds of issues. So although you haven't explored the online discussion forums in your previous classes and you want to do it now, can you maybe like say a few names so that we can also look it up and we can try it out as well? So yeah, so those are my two questions. Thank you.
Yeah, absolutely, Professor Ghosh. So thanks for the questions. Let me address one by one. So just to be clear, and again, I realize I must have not been clear enough on this. So there are two kinds of quizzes that we had when the video material lectures are handed out beforehand. The first is just to test, it's like attendance, except that it's just to test that they have gone through the material. So randomly on 8 or 10 classes sprinkled throughout the semester, they come into the class and first 10 minutes there would be a quiz. The quiz is based on the video material that they are assigned to watch before they come to the class. And it does not assume that they have understood the material. So these are the simplest of recall questions. That what did the video say about this or that? Okay, and you may not have understood the terms, but you have heard the terms. So it just sort of incentivizes the students to go through the video so that they don't waste their time sitting in class not understanding what is going on. And it's I tell them that it's free points. Just watch the video and these points are yours for the taking. So so that's one kind of, and the total weightage of that would be maybe 10% or so. It's like attendance, giving some weightage for attendance. And then the other quizzes are more standard quizzes, mid-sem, end-sem, which are conceptual. So actually these recall type things, which is incentivizing the watching of the material, is not conceptual at all. Does that answer the first question?
That answers my question. Thanks. Yeah.
Okay. And the second question is, I'll just, while I'm at it, I will share with you the platform that I'm trying out, that we have an offer to try out. It's called Yellow Dig. And I also promised, not just in this context, but generally if there are questions or you want to discuss some more about anything that I have talked about, then please feel free to reach out. So this is my number. We can discuss at more length offline. Of course, my email is available. Is online.
Okay. Okay. Thank you, Professor Ganguly. Thanks. Yeah.
Sure.
Professor Swaroop, there is a question on the chat box for you by Professor Nitesh Yevgle.
Yes, I see that. Yeah, thank you, Professor Yelve. So let's just read out the question. Whether the flipped class is similar to self-study work given to students where they are given pre-recorded videos or slides or notes. So the flipped class is, so half of it half of the flipped classroom is indeed that they are asked to go through pre-recorded videos or slides or notes. And that is, in some sense, as Professor Sahanamurthy was saying, that is the easy part. For many standard courses, these videos might be very, very good quality course videos might be available, if not from IIT Bombay, then from other sources like, I mean, there are so many other sources from where you can get them. The other part of the flipped classroom, and this does take a lot of work. So there is I mean, a traditionalist could be forgiven for thinking that, oh, you have got all the lecture materials from somebody else. Let's say if you are taking it from, if you are getting the videos from somewhere else, so you are really not doing any work, and that is just wrong, because if you have to design the in-class problems so that you want to structure the problem in a way that you give them 4 choices, and it none of let's take that example, right? So you want to do peer instruction, which means that you will ask students to think about it and vote for it first, and then you will ask them to go and discuss. And I typically like to sort of present it like a fight, like find somebody who disagrees with you on the answer and fight it out. Each of you try to convince the other and then come out with a combined answer. So to come out with questions, non-trivial questions, which will have 3 or 4 choices, and 3 of them cannot be very easy to immediately eliminate. So, and to have sufficient number of those questions, 3 or 4 of those questions for every class, is a non-trivial amount of effort, I can assure you, from several years of first-hand experience. But yes, that is the other part of the flipped class. Have I answered your question, Professor Yelve?
Yeah, sure. Thank you, sir.
Thank you. Okay, so I don't have, of course, anything else from my side, and I realize I have significantly gone over time, so apologies for that, and thanks to Professor Sachin Patwardhan and the PPCCLT team for this opportunity to talk to all of you.
Yeah, many thanks, Swaroop and Sahana, for a very interesting session. And I think the first session and the second session, they continued to join quite well. So we'll now move on to the next session.